Hello students, today we will solve question number 9 and 10 from exercise 5.2 NCERT Mathematics book class 12. So without a further ado, let's get started. See, question is prove that the function f given by fx is equal to mod x minus 1. X belongs to real number is not differentiable at x is equal to 1. So solution. So we have to prove. So first we will find left hand derivative. Limit h tends to 0 minus 1 f c one plus h minus f1 divided by h is equal to limit h tends to 0 minus f1 plus h, it's 1 plus h minus 1 mod minus mod 1 minus 1 divided by h is equal to limit h tends to 0 minus 1 will be cut here. So this will be mod h minus 0 h. This is minus because this is less than 0. This is h is less than 0, so this will be minus h minus 0 divided by h is equal to minus h by h. This will be cut, so this will be minus 1. Now we will find a right hand derivative. Zero plus f 1 plus h minus f1 divided by h is equal to 1 plus h. So 1 plus h will be limit h plus mod 1 plus h minus 1 mod minus 1 minus 1 divided by h is equal to limit h tends to 0 plus see this one and this one will be cut, so it will be mod h minus 0 divided by h is equal to limit h tends to 0 plus, because this is less greater than 0, so this will be h minus 0 divided by h is equal to limit h tends to 0 plus, this is h by h, this will be 1. So here we see that limit h tends to left hand derivative f1 plus h minus f1 by h is not equal to a right hand derivative. Left hand derivative is not equal to right hand derivative, so therefore f fx is not differentiable. Therefore fx is not differentiable. At x is equal to 1. Question number 10. Question number 10 is, let's see question number 10. Prove that the greatest integer greatest integer function defined by fx is equal to 0 is not differentiable at x is equal to 2 and x is equal to x is equal to 1 and 2. And x is equal to 2. So we have to check the differentiability at x is equal to 1 and 2. So first we will check at x is equal to 1. X is equal to 1. So first we will find left hand limit. F 1 plus h minus f1 divided by h equal to limit h tends to left hand derivative 1 plus h minus 1 h limit h tends to 0 minus, because see h is less than 0 because this is left hand limit, so h is less than 0, so it will subtract from 1, so it will be less than 1, so therefore the greatest integer like this, suppose this will be less than 1 means 0.9, like that, this is less than, so its greatest integer will be 0 minus f1 1 by h. So here will be when limit minus limit h tends to 0 minus 1 by h. So this will be infinity. You will divide minus 1 by 0, so it will be infinity. Now we will find a right hand limit. A right hand derivative 0 plus f1 plus h minus f1 divided by h. So here will be f1 plus h. f1 plus h will be a limit h tends to 0 plus 1 plus h minus 1 divided by h. So this will be 1 plus h, means it will be greater than 1, so its greatest integer will be limit h tends to 0 plus it will be greater than 1, so it will be 1 minus 1 divided by h. So this will be 0. This will be limit h tends to 0 plus 0 by h. So this will be 0 because 0 by h. H is not 0 here, h tends to 0, that's why 0 by h is equal to 0. So you don't consider that this is in determinate form, because this is 0 and this is h is not exactly 0, it tends to 0, so 0 divided by h will be 0. So here we see that therefore limit h tends to 0 minus f1 plus h minus f1 divided by h is not equal to limit h tends to 0 plus f1 plus h minus f1 by h. So therefore fx is not differentiable at x is equal to 1. Similarly, we can prove indifferentiable at x is equal to 2, x at x is equal to 2. So left hand derivative limit h tends to 0 minus f2 plus h minus f2 divided by h is equal to limit h tends to 2 plus h. So this will be 2 plus h minus 2 divided by h. So because h is less than 0, so it will subtract from 2, so it will be like 1.999. Suppose 1.999 like that. So its greatest integer will be 1. 1 limit h tends to, this will be 1 minus 2 by h is equal to limit h tends to 0 minus 1 by h. So if we will put the value, this will be infinity. Now right hand limit h tends to 0 plus f2 plus h minus f2 divided by h. So here will be limit h tends to 0 plus 2 plus h, so it is greater than 2, so this 2 plus h minus 2 divided by h to limit h tends to 0 plus 2 plus h, it will be greater than 2, so its value will be 2 and minus 2 divided by h. So this will be limit h tends to 0 plus 0 by h. So this will be 0. So here we see that since left hand derivative is not equal to a right hand derivative. Therefore, function f is not differentiable at x is equal to 2. So this is problem. I hope you must have understood these solutions. Today up to here. We will meet in the next session with next questions. Till then, take care. Thank you.